Today we will discuss here about the relations and function. We will revise the chapter 1. Before starting the discussion, first we have to analyze what are the contents of the chapter. As its name is suggesting, you may see, you keep open your NCERT textbook also while solving or understanding the topic. Is it here? Functions and relations. What are the objective of this chapter? Function and relation. First we will discuss about the relation. What do you understand by the term relation? Obviously earlier we have discussed about it here. Right now take a in this year we'll take a quick revision, or we can we'll solve some numericals also, but very fast or rapidly we'll move this syllabus. Is it here? So functions and relations. What are the contents of this chapter here? First is relation. Relations will be of three types, and second, wait please. We will discuss here about relations. Relation means in the chapter relation. Relation is what type of relation here? That is called equivalence relation. We will discuss here in the chapter equivalence. Equivalence relation. What is called the equivalence relation? A relation is said to be equivalence if it is reflexive. Second is what? If it is reflexive, it is symmetric, okay, and third, it is transitive. Is it here? Reflexive, symmetric, or transitive? Transitive. Then the relation is said to be equivalence. The second content of the chapter is function. So what the function is? Here we study function is what here? Bijective. We will study the bijectivity of the function. And which function is said to be bijective? The function which is 1, 1. This 1, 1 is called into, or also it's called injective. Is it? And the second type function is what here? Onto, or this is also called surjective. A function which is both injective and surjective, into and onto, that is 1, 1 and onto. The function is said to be bijective. Is it? These are the two contents of the syllabuses here. Right now, compositions of functions also were the last year, but this was right, and inverse function concept also were present, but the last year this was. In this year only the two topics are here. However, some compositions of the function variable we will solve them. Is it? Equivalence relation. The difficulty in this chapter is to write down the solution. The main difficulty is to write down the solution. How to write solution? This is the difficulty here. Is it here? So I am telling how I will describe here also the method of writing solutions. Is it here? First we will describe the word relation. What do you understand by the term relation? So I will just call the previous knowledge, the 11th class year you have studied about here. What the relation is? Suppose that I am taking here a set. The set is what here? The set is like 1. Got it here? The set is here 2. Here it is 3. And here it is 4 and something else. Right now. And the second is also B. Is the set of number like that B. Is it? Here it is C. And here it is D. And further E also. Is it? It means there are the 3 members in this set, there are the 4 members in this set here, right now. If I will arrange every element, I will make the order pair of every element, E element of first set with second set. Is it here like that? First arrangement will be 2 with B. Is it or not? Now second 2 with what? C. Now here 2 with what? D. Similarly, dot 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 dot. 2 can come with B, C, D and furthermore. Is it? This is that. Or here similarly 3 can come with B, 3 can come with C, 3 can come with D and so on. Is it here? Here 3B will also come with that. Similarly 4 will also come with that here. Is it here? Means all collections of all ordered pair which are made as a first member of from the first set and second member from the second set. Is it here? This collections or this arrangement or this collections is called the Cartesian product. When one sets every member is associated with every member of another set in ordered pair manner, then the collection of all ordered pair from set A to B is said to be what? Cartesian product. Right now it's called Cartesian product. If I am talking about some special of Cartesian product, like that I am talking about 2B and here 3 of C and here 4 of D, is it or not? Only. I have taken some of the element from among them. Right now, like only 3 elements I have taken from them. Is it here? So why not the other element you had taken? Because these element is following certain rule. I don't want to decide what the rule is they are following, but only these 3 are following that rule. So that rule is actually bringing these all 3 elements together. So under that condition, these we can say also that these 3 members is following that rule. Is it here? That rule is actually bringing them together as a set. Right now, so this set, what is the name of this set we are giving? This set is said to be a relation set, means certain condition, certain rule that brings to, or what we can say, what type of set is this here? This set is how associated with this set. So some members taken together and made a set here, like a subset it is. So this could be a subset. So this relation set is the subset of A cross B. Is it here? And there will be some relation, there will be some condition that could be followed by all element even. It means such a relation can also be made that will be followed by all the member. Is it here? So this is the relation. So what are the relation? A relation actually, and in this relation we are taking the first element from the first set and second element we are taking from the second set. Is it enough? So what is the definition of relation? What is the definition of relation? So a relation from A to B, a relation from A to B is given as, it is collection of all the element A, B, where the first member will be from set A and the second member will be from set B. Here not necessary to write down for all, because this is the relation I am giving its name R1, right? It's not necessary that all the member of A will follow that relation. Some member can follow. Is it here? So this is called a relation. So what are relation? So relation is a collection of all ordered pair taken from Cartesian product of A and B set is called relation. Is it here? So this is we have revised from the 11th class. Now types of relations are here. First is the reflexive relation. So what the reflexive relation? So we can see that here there is a member A. Is it here? If this member A is standing before mirror, it is standing before mirror. Is it not? So when it will stand before a mirror, and how it will appear that here? Obviously he will see himself in the mirror. Right now it means the domain is A, or what he is observing inside the mirror, image is also A. So under what happening, it is getting the same, that's called relation. So what relation? Is a reflection he is obtaining himself as an image. Is it? So this relation is said to be reflexive relation. So what the reflexive relation is? Obviously a relation from A to B is said to be what, please tell me? Reflexive. Is said to be reflexive if, what that here? AA belongs to R. AA belongs to R means what? Under that relation, if we'll put the value domain A, it will give the image A. This is called reflexive relation. Is it here? Now the second, symmetric. What the relation symmetric here? Exactly, a relation from A to B is said to be what? Symmetric. Is said to be symmetric. Symmetric. If, what is that here? AB belongs to R, means under that relation, A is giving B as image. Is it? Then under the same relation, for domain B, A will be image. Is it here? Then such relation is said to be symmetric. Symmetric means A will find B as an image. B will find A as an image. Like that, this and this. Is it? That is A plus B and B plus A. 2 plus 3 is 5 and 3 plus 2 again 5. Is it here? It means plus is an operation which we are applying between the two integers 2 and 3. Is it here? So it's giving the same result. That's why AB and BA will give the same result. Then this relation is said to be reflexive. Is it here? What the third relation? Transitive. A relation from A to B. Here we are giving the name. This is suppose R1 relation, this is suppose R2 relation, or this is suppose R3 relation we are taking. Is it true? R3, a relation from A to B is said to be what? Transitive. This is said to be transitive. If what? AB belongs to R. What is the meaning of the word AB belongs to R? Means under that relation A related with B and BC belongs to R. What is the meaning of this statement? Under that relation B related to C. Due to these two results, under the same relation AC will also be, is it here? AC will also belongs to R. That is what? A related with C. Is it here? Due to these two results, this result will be obtained, exist here. Is it here? This is called transitive. A relation is said to be transitive. This is here very decision making operator here. Implies that. Means this will be caused by these two and this will be caused due to that. So a relation that is reflexive, symmetric, transitive. Here this is symmetric. And this is transitive. And this is reflexive. A relation which is either thrice reflexive, symmetric or transitive is said to be equivalence. Is it? This is equivalence relation. Is it? Now, clearly understood here the meaning of the equivalence relation? We'll solve the sum numerical. Suppose that T is a set of what here? Please tell me. T is a set of what? Triangle. T is a set of triangle. T is a set of triangle. Okay, T is a set of T where T is a triangle. Is a triangle. Is a triangle. Is it here? A relation on T is given. A relation on T. What is the meaning of the word? A relation on T. Relation on T. Relation on T means what? It means for the relation, first member you will take from T set and the second member as image you will take from the same set. Right now, that's the relation on T it is said. A relation on T is given is given as, how it is given as? As given as are T1 and T2, means both the T1 and T2 are here what? T1 is congruent to T2, where T1 and T2 belongs to T, is it or not? Prove that this is an equivalence, this is a reflexive relation. So how can we prove this is reflexive? I will tell in a single question: reflexive, symmetric, as well transitive. Is it here? So how will you write down? So now I am telling the reflexivity. Reflexive. How the reflexive can check here? This is the method of writing solution. Okay. So you will suppose here let T1 belongs to T, means for a triangle which we are taking in a set. T1 belongs to T, there T1 belongs to T means T1 is a what? Triangle. T1 is a triangle. Is it or not? T1 is a triangle. Then what you will take here? So T1 and T1 will belongs to R. What is the meaning of the T1 belongs to T? Conclusion: T1 is a member of T. Is it here? So we have to prove reflexivity. So what is the relation actually? The relationship is this here. Congruency. So does a triangle congruent to itself? Yes. Here you will write, since triangle T1 is congruent to itself. That is, here you will write in the word. Every triangle is to congruent. What? Every triangle is what? Congruent to itself. Every triangle is congruent to itself. Is it or not? That's why T1 congruent to T1, right? Now, therefore, T1 and T1 belongs to R. Conclusion: here I have written every triangle is congruent to itself. Means here it is in the word I have written. Here I have written in the symbol. Therefore, what you will write here? R is reflexive. Well, understood you or not? How the reflectivity is to be written here? That therefore R is reflexive. Is it? First part of it. Now second, symmetric. Symmetric. What is the way to write down symmetric? You will write here T1, you will consider that. Let T1, T2 belongs to R. What is the meaning of this statement? Suppose there are two triangles which is following the rule. That is, T1 is congruent to T2. Here you can write in the word a triangle is congruent to. That is, you will write here a triangle. One triangle is congruent to what? Another. One triangle is congruent to another. Here I have written this statement in the word, the same symbol I have written as a word, right? T1 is congruent to T2. Will the second triangle be congruent to first one? Of course, sir. If one triangle is congruent to second, the second is also congruent to first one. Is it or not? Can we write that? Therefore, T2 will congruent to T1. Why? Here you will give the justification. Two triangles are congruent to each other. Is it here? That's why what could be written here is, here T2 and T1 belongs to what? R. Therefore, R is reflexive. Sorry, R is symmetric. R is symmetric. This is the way of writing that here. The verbal expression could be written according to your knowledge of language. Is it here? But operator sign here therefore implies that everywhere is to be placed properly. Now next is transitive. Transitive. We'll consider that here. Let same it is T1 T2 belongs to R. What is the meaning of T1 T2 belongs to R? That is, what is the meaning of that? It means T1 congruent to T2. Is it or not? Now again, T2 T3 belongs to R. We have supposed that here. That is what? T2 congruent to T3. Is it or not? So from these two relations, that's why one triangle is congruent to second, second is congruent to third. Can the relation be given between these two? Yes, of course. Therefore, here you will write T1 will be congruent to T3, implies that, or that is T1 and T3 will also belongs to R. Here we have proved these two results, we have achieved this result. Is it here? Here you will write implies that. Is it? Implies that this. Got it? So, what is that here? Relation R is what? Transitive. Transitive. Now a relation which is reflexive, a relation symmetric which is right, and the third one a relation which is transitive, it is said to be equivalence relation. Some of the students think that proof of the equivalency, sir, we have proof here that. So we go on writing that here. Obviously, it is earlier given at an answer here that the relation is equivalence is predefined. Then we have to write the statement, and finally we have to write hence it is equivalence. But the statement writing is actually will check your skill of solving in that. Is it here? So there are well understood the reflexive or symmetric or transitive. These typical questions may come in examination. However, are very simple or moderate type questions I have taken to explain the concept of equivalence relation. Is it or not? Now next, second topic, that is function we are discussing. Is it here? Function. Or what function we have to discuss? Bijective function. Bijective function. Your contents of the 12th class is bijective function. So which function is said to be bijective function? A function which is onto, one or onto, that is into and onto. Is it here? Injective plus surjective. Here you will write injective plus what is that here? Surjective. Injective plus surjective, that is equal to bijective. So first we must know what is the meaning of injective. Injective is called what? One. Or surjective is called what here? Onto. Onto and into, or one also. Is it? So what the one and into? A very familiar example I am giving you. First we have to define the word function. Take a quick revision about the function. When do you say a function is there? Here is a set. A very familiar example I am using here to explain that. Here elements are A1, A2, A3, A4. Here elements are B1, B2, B3, B4, B5. So obviously this is that. It is this. Could you see that here? Every member of the set A is engaged with at least one element of B set. There is no any member which does not have image in set B. Each element is having image. Is it here? But if I would write here this like this. Now, is it? So here I am writing mapping relation from A to B is a function? No, it's not a function. Why? Because A4 does not have image. Is it? If A will have image here, A4 will have the image, then it's become function. So sir, what about B? For defining function, we don't look the members of B. Is it here? And here one thing is more important. That's what? A1 associated with B, B1 under certain rule, and this rule is said to be a function. This is, got it? Or it's called a function set. That is F is A1 B1, is it or not? Or here is what here? A2 and here it's a B2. Similarly, A3 is also associated with B3 and A4 associated with B3. Sorry, it's a B2. It's a B3. This collection or relation is said to be function. So what is a function first defined? Function is what? A relation from A to B. Sir, you are giving the definition of function and speaking relation by special condition of relation is called a function. If I will not give the image of A4, then it will be relation. But if I will give the image of every element of set A, then it will be called a function. So function is a special relation. Function is a special condition for relation when every element of A has one and only one image in set B. Then this is called. Got it? Means every element has at least one setting. At least one will not be used here, the word at least, because a single element cannot have more than one setting in element B. A will have only one setting in B, is it? But B member, a single member of B can be associated with the two or more, is it? So this A is called what here? Dome of function. Or this B1, B is called the image. Collections of all images called range. Is it here? And this set is called codomain. Is it or not? So this is a function. So which function now? Let's come to that syllabus. Injective and bijective. So which function is said to be injective? So before starting that, we'll just take some illustration which have been given in your textbook right now. Here it is that. This is your textbook. Some example have been shown here. This is that here. Look that. Could you see that? Now look at the first type. It's a set x1. It is x right now. 1 has the image A, 2 has the image B. Is it 3 has the image D or 4 has the image C? Does every member associated at least one? Yes, sir. So this mapping is called 1-1. This mapping is called 1-1. What is the definition of 1-1 mapping? A mapping under which every element of a set has one and only one image in another set. Then this mapping is called 1-1 or injective. So can we speak here a definition, real definition of function is 1-1? Obviously, sir. Very initially, very beginning in function first become 1-1. Is it? Is it function? First check that here. Yes, sir, function it is. 1 with B, 2 with B, 3. What about B? B is the image and 1 and 2 for B are pre-image. Means under function, some element can have the 2 pre-image, but element cannot have 2 image. Is it not? No any member is unengaged. Means no any member is empty, vacant. No any element is vacant. Every element is engaged. Is that clear? That's why, what type of mapping is this? Sir, but it is not. It's not 1-1, sir. Because sir, look that B has the 2 image. Pre-image, sorry. So what type of mapping is this? This is called many to 1. Is it here? If this is a function, will it be 1-1? Yes, first it will be 1-1. If it is not 1-1, then it will be many to 1. So a function, a theorem can be achieved here, ready-made result. A function which is not 1 1, obviously it will be many to 1. Is it or not? This is many to 1. So it's 1 1. This function is 1 1. It's called injective. This function is what here? Many to 1. This is many to 1. Right now? Or what about this? Sir, it's 1 2 have the single element. Is it here? So first it is function. First it is function. But what pattern you are observing regarding this? In this case, E and F are unengaged. Is it not? Means they do not have pre-image. In this case, E and F are unengaged. Is it? That is not have the pre-image. In this case, what pattern you are observing? What pattern? What order now do you have? Yes sir, there is no any element in set X3 or the second set which does not have pre-image. Right? No any element is there. Every element in the second set has the pre-image. Is it here? Then this is means on the basis of second set, we observe the second set. No any element is there, which is vacant. So this is called onto. This is called onto. A very interesting thing here. The definition of onto is always given. The definition of onto is always given to see the codomain set. So tell please, what is codomain here? Sir, X3. That is collection of A, B and C. It's a codomain. And what is image? Oh sorry, what is range? Sir, range is also same. Range is also same. A, B and C. So can we speak here, when range becomes codomain becomes range, then the mapping becomes onto. Is it here? A mapping from A to B is said to be onto if the codomain becomes range. Range is the collection of all element from the second set that is keeping relation or that is that are associated with the elements of previous set. Is it or not? So it is many to one. Finally, what you have to keep in mind, definition of onto is given on the basis of second set. Whenever we'll see onto, we'll see the second set. Here what about? Sir, we'll see that first set. 1 has 1 element image, 2 has 1, 3 has 1 and 4 has 1. Means this is 1 1. This is 1 1. And to see the second set, is there an element vacant? No sir. This is also onto. So from the left side, it is 1 1. And from the right hand side, it is onto. Is it here? So this is an example of function which is 1 1 and onto. So this function or mapping is called bijective, or got it? Bijective, or it's called also injective plus surjective. That's a bijective. Got it or not? So what is the definition of bijective function? A function is said to be bijective, which is 1 1 or 1 1 and onto. You may write down the definition. A function from 1 1 and onto, 1 1 and onto is said to be what? Bijective. An example. Look at here. Here are some questions given here. I am explaining you this question here. Like that this. Exercise. Show that a function, example number 8. The method of writing solution I am telling again, okay? Since a function on n. Function on n means end to end. Domain you have to take from the natural and image you have to take from natural set. It's called function on natural set. Is given as, how it is given, please tell me? It is given as fx is equal to f is equal to 2 of x. Do you know what type of function is this here? Yes sir, linear function. What type of function is linear function? So we have to prove this is what the questioner is saying here. On to prove that this is 1 1 but not on 2. We'll not see the what he is asking the question. We simply will go with 1 1 and on 2, and then we'll justify whether what type of mapping is given here. This. Got it? So we'll check first here 1 1. Is it here? How the 1 1 is to be checked? Simply 1 1 means what? What is the definition of 1 1? Every element from this set will have one and only one image. You suppose that here it is there. Let n be b. Is it right? Here you will write down. Let n1 and n2 b are the what here? N1 and n2 are x1 and x2. x1 and x2 are two member belonging to, means x1 and x2 are two natural number. x1 and x2 are two natural numbers. Suppose that. Is that clear? And under that function f of x1, whatever is being given, is equal to f of x2. What is the meaning we have supposed here? Means we supposed here that two images. Listen carefully. Two images are equal. We have to take here, right? That is what. So what the function is given? This is the function here, right? So that is 2 of x1. Here we are taking 2 of x2. Now we have to apply mathematical operation. This 2 can be cancelled. What's coming here? x1 and x2. Is it or not? What do we conclude here? So domain came equal. It means if you will take image equal, then domain will also come equal. What is the conclusion? Due to domain equal, image is coming equal. Means on equating the image, domain is coming. It means there is what? Only one image is existing with the one domain. That is called member of the domain. Is it here? Means only one image is associated. If here will not come here. x1 will not come equal to x2. Is it? What will meaning of that here? The images are two. Images are single, but the domains are different. So what type of pattern will here this? This type of, got it here? It means this will be many to one. Right now? So a function which is not 1 1, here it will be many to one. So tell please, on equating the image, the domain is coming equal. Is it here? Then it is, therefore f is 1 1. F is 1 1. Simply, got it? This is the way of writing the solution. If images are equal, implies that domain are equal, then function is said to be 1 1. Now second, onto. How onto is to be proved here? Onto means obviously our side begins from the second set. Right? Now second set means what? Here you will suppose onto means let. Here function is what? F of 2x. Is it here? Where x is what here? X is natural number. So obviously here this we will suppose a single variable like that y. Y is actually 2x. So we are giving the function from n to n. It means domain you will take from the natural set and range you will take from image you will take from the natural set. Here it is also where y is also natural. Got it or not? So what implies that? Here we'll discuss 1 by 2 will be transferred here, y is equal to x. Is it here? So we can say that under means from A to B. Here look that. Under F1 we go from 1 to A. Listen here. Under F1 we go from 1 to A. Means under F1 function 1 give the image A. Under the inverse function means from B to A. Under the F inverse 1, A give you 1, B give you 2, C give you 4. Under F1 inverse, same here. Under F function, x is giving you y. So under f inverse, y will give you x. Is it here? So what about x here? Tell please. Obviously it is. So therefore, if you will take y is equal to 1, then x is equal to 1 by 2. Is it or not? If x is equal to, an example I am giving you right now. If illustration x is equal to 1 implies that, y is equal to 1 implies that x is equal to what will here? Half. If y is equal to 2, y is equal to 3, then what about x is equal to 3 by 2? Are these natural? No, they are not natural. It means when y will be 1, when y will be 3, when y will be 5, y will be 7, for these y, whatever the x pre-image will come are not natural. It means there are some y which do not have pre-image. Is it? It means all y are not engaged. Some y are vacant. Some y are vacant. Is it here? So here you will write the statement. There are what? There exist. Here you can write. This symbol also you can use here. There exist some y be natural, which does not have pre-image. in the set. So what you will write here further? Therefore, f is not what? Onto. F is not onto. Hence we have proved here that it is 1 1 but not 1 2. So main difficulty yours is writing steps of the solution. Is it here? That is this. Hope you understood you. Bijective proving, and if this were onto, then the function could further written as a bijective. A function which is 1 1 and onto is said to be bijective. Is it here? Clearly understood you? Some more questions we are discussing here. That here. It is that here. Like that it is. Show that an onto function is always 1 1. An onto function is always 1 1. Onto function is always 1 1. What is the meaning of onto function is always 1 1? Onto is always 1 1. Is it? And onto is always 1 1. Wait a minute. Onto is always 1 1. By giving some illustration. It's a set A or it's set B. I just want to raise your confidence. In an examination, you can write down the solution in this set manner also in mapping form. Is it here? Here it means 1 1 a function, so that an onto function, onto what the function is, since f from set what? From set 1 2 3. A function from 1 2 3 to what? 1 2 3. This is a set A here. Here we'll take here 1 1 2 3, or here also 1 2 3. Is it what the question is saying here? Mapping from A to B. What the question is saying here? Show that an onto function is always onto function. It's well clear that it is given onto. Onto given means what? Obviously, I'm giving an analytical solution. X belongs to A implies that f of x belongs to B, or this f of x we can suppose as a B, right? So here the condition given, if all y, what do you have, please tell me? If all y belongs to B has what? One what? Pre-image. All y belongs to B has a pre-image. Then what? Then f is onto. So you are to prove this is what? Show that an onto function is always 1 1. We have to prove. Got it? Tell please. It is onto, well clear. So we have to prove this is 1 1. Is it? So obviously it is f of, look that, f is onto, well clear. There is no, suppose here two image y1 and y2 belongs to B. So we are taking this as y1 is equal to y2. What the meaning here? It is same. Suppose it is same. If it is same, then here in place of we'll write what? F of x1. Here we'll write f of x2. If the function is same, then function could be cancelled here. Is it or not? The conclusion, if you will take the image same, then domain will come same. It means one image has only one pre-image in first set. That is 1 1. A function which is onto, it will be 1 1. Is it? This is the analytical provement of this question. But on this way, how can we prove that? Simple it is. Let what? One associated, one, here it is that here. Means there is no any element associated with this. Is it element associated with that here? No. Why? Because here it is the association with 2 will with 2. Means 2 will associate with here 1 and 2. Which is not a function definition. Is it? This is analytical proof. So here you will write f of 1. Suppose f of 1 is giving 1 and f of 2 is giving 1. Is it here? So under the same inverse function actually is not the, it is in syllabus yours. Okay, f1 is giving you this analytical proof I have given here. You will just give a exemplar proof here. Right now? Now come on please. Some more questions are here given. You will prove that. And later we'll discuss about some more questions. Is it here? Here it is that. Now composition of function, later I will discuss here that. Is it? Got it? So I'm revising the concept here. What we have discussed in the types of mapping and function. Here it is. First we have discussed about the types of function. It is this here. Bijective function, injective plus surjective. Okay. So the main difficulty I have get rid of that, get rid of you from this problem of writing solution. Is it here? I have closed it here. Right. Now take out this example here.